Okay, so that's not the worst thing ever. Hopefully those first two examples were on the easier side. All right, so what now? So now we're ready to set up the integral. So it's going to be the integral from, so which way do our washers stack? Do they stack bottom to top or left to right? Left to right. The first one then is x equals 0 to x equals 8. And then we're going to what? We're going to add up all these washers. So let's factor out the delta x and just make it dx. So it's going to be pi 70 squared minus pi 70 minus x squared squared. That's all dx. That will be the volume of the flat bottom bowl with the hole in the bottom. Getting harder. Any questions on that? Please. Sure. Well, this is just pi times the rest and pi times the rest. So you could just pull out one pi, put it in front. Totally. What's that? Yeah, because you're subtracting and you're just factoring out a pi. Yeah. Other questions before I erase?
I understand why we're rotating around x equals 8, but I guess the part where it's up there.
I guess I don't understand the question. How do you know that you're rotating about y equals 70, or how do you know what that looks like? So this was 64, and so y equals 70 is a horizontal line up above it. So you just have to have some imagination here, like visualization. You've got this thing, and you're going to rotate it around. So like this point, where is it going to rotate? It's going to end up at 180 degrees. It's going to end up here. And this boundary here is going to end up like this, right? And this boundary here is going to end up like this. And the x-axis is going to end up at what? 140. Y equals 140, right? Rotated around 70, up like that. That should not be hard to do. Okay, and so you imagine that thing right there getting rotated in 180 degrees, it looks like that. So then all the points and all the vertexes and the edges just make a circle, right? So here's the original region down here in red. And then here it is when it's rotated 180 degrees. So yeah, you got to practice your visualization, and it doesn't have to be a perfect sketch, but you got to have at least good enough so you know what's going on. Does that help?
So the new regions is between there minus the...
What's that?
So that new regions is that whole area minus the intersection?
No, so then we need, this is the volume, so we're going to have a typical element of which all of them together will form this big solid. And the typical element comes from taking a typical strip in the original region and rotating it the same way that we rotate the region. Okay, so I got this typical strip. I'm going to also rotate it about y equals 70, and that's where I get this washer. So because when that little strip goes all the way around y equals 70, when it's at 180 degrees, it's like this. And so you imagine this coming out at you like this, and then flipping over, and then going back into the screen, and you're going to get this thing. You see that? Because like the typical strip that I started with would be right here. And you imagine you rotate that around y equals 70, and you're going to get this washer. And now we find the volume of a typical washer, and then we stack all those washers sideways from like this, and it forms the solid. So there's the rotation of the region at first, but then to get the typical element, you have to rotate the strip that's in the region. And what do you get when you rotate that strip? You get the washer, and then you add up all the washers, and it gives you the region, the volume of the region. Okay. Any questions about that? Okay, so new one. So no, let's just practice. I won't make a volume out of this, but just you've got to know how to do this. With or without your calculator. Go. See if you can do it. You can use your calculator, but you got to know what you're doing, okay? Can you sketch that whole curve? X equals y squared plus 3y. There will be problems where you'll have to do this and you'll have to be confident. You can talk.
How do you know whether to drop it down this way or that? Or just say, just do the same thing you would with an X. Grab that with an X. Just set y squared plus 3y. Just set y squared plus 3y. And then solve for y. And it's just yeah, so it's open. Positive. Yeah. Yeah, though.
Okay, then you got some more work here. So check that with people around you. See if you should be able to sketch that with or without your calculator somehow. Got to get that right. And then here's a nice problem to work on. And then I'm going to take attendance. Work together, okay? First of all, here's that curve. This is -3. And this is 0, 0. So it goes through 0, 0 and 0, -3, and it opens to the right. Did you get it? So one possible way to do that is to, if you want to keep working at, if you got that curve and you want to work on number 2, go for it. If you're puzzled how to get this curve, one strategy is just change x and y. You could graph that. Graph will show up nicely on your graphing calculator. And then you know that it opens on the positive y-axis and goes through -3, 0. So this one will open on the positive x-axis and go through 0, -3. So this opens on the positive y-axis. This one opens on the positive x-axis. Switch the coordinates of your roots. 0, 0 will stay 0, 0, but -3, 0 will be 0, -3. So that's one way to get that curve.
So for finding the area of the region, it would be essentially.
Now this is a different problem. These are two totally different problems. This has nothing to do with this. You knew that, right? You sketched this curve, but then this is a different problem.
I didn't start reading that one.
Okay.
I was just saying, if we were to solve for the region of the area, either area, that would be the same problem.
What now?
Like in the first one that you
Oh, if you want to find the area of this versus the area of this? Yes, it would end up being the same area, but
one would be
I could
easier.
ask a question so that you're forced to do this, you know? But yes, if you're just asked purely what's the area of the region, they would have the same area. Okay. Okay, how's this coming? Curved on that. There we go. Oh, I should have told you to do it. Horizontal strips stacked up this way. If you do vertical strips, you don't get washers or pancakes. We'll do that on Wednesday. Okay? But in order to get washers or pancakes, you got to do this type of strip. Okay, so you should have gotten a. What is this thing? You should have gotten one of those. It's pretty decent. So this is something like a bundt cake. You know what a bundt cake is? It just has on the inside, it has straight sides instead of a rounded side on the inside. So this is something like a trapezoidal bundt cake. How's it coming? Is this making progress? So we need what? We're going to have a washer like this. That's the best washer I've drawn all day. Okay, volume of one of those is volume of outer minus volume of inner. So volume of the washer. Outer volume of the washer is pi r outer squared h minus pi r inner squared h. And so we got to get our inner and outer radius. Okay, so here we go. Here is, from here to here, is the inner radius. It's supposed to be an I. There's the inner radius, from here to here. Who's got it? Because I'm doing inner first. So this is minus. What is the inner radius?
9 minus parentheses 6 minus y.
So let's do all steps here. So 9 minus x of the line, right? It's the x coordinate of the line. I think what you were saying was right. I just want to do every step. H is delta y. Okay, outer radius. Okay, if you're just thinking you're going to write this down and figure it out later, that's a recipe for disaster. You've got to understand this because you've got to come up with it yourself. Okay, so outer radius now is all the way from here to this point. And what's that? It's also 9 minus x, but x for the outer. So it's called x outer, x inner, I guess. And distinguish. And that's also delta y. Okay, now we know it's delta y, so we got to get it in terms of y. So what is the y coordinate of the outer radius? X naught equals y squared. It's x equals y squared. Minus pi times 9 minus, what's the x coordinate of the line? 9 minus parentheses 6 minus y times delta y. And it's that thing is squared, yeah. Try it again. got it. So it's 9 minus the inner radius, which is the x coordinate of the line, and the x coordinate of the line is 6 minus y. So 9 minus quantity 6 minus y, all squared. And then our volume will be? So yeah, so from what to what? So is it from bottom to top or left to right? Bottom, it's dy, and these are stacked up this way. These washers are stacked like you could stack them on your tool bench. So it's 0 to y coordinate of this point. This is the point 4, comma 2, I believe. So it's going to be 0 to 2 of pi times 9 minus y squared, quantity squared, minus pi times, can I solve it here? 3 plus y in there. All dy. We want to get time for one more. So ask me. These are getting hard now. If you can do this one and the next one, you're in good shape. These are the hardest for this washers and pancakes. Last quick chance for a question. Yes, please.
Just in general for the answer, do you just plug that in and you calculate it with the integral?
No, you do it. It's an easy integral, right? It's just, yeah. So you can multiply that out and you just got polynomials. This one you could even do, you could just keep, you don't even have to multiply that. You could just raise power and doing the chain.
For the outer, like, see RI, you know, see the inner with the outer, as far as determining R.
So it's from here to here. That's our outer. Do you see that? So it's from the rotating axis to the curve. That's the outer radius of the washer. So it's going to be 9 minus the x coordinate on the curve. Because the x coordinate, this is the x coordinate on the curve. So 9 minus x would be this outer radius. But then we need it in terms of y, because it's delta y, so on the curve, x is the same as y squared. So then it's 9 minus y squared. Last chance for a question. Okay, same region, rotate about y equals negative 2. Okay, you want to use vertical strips on this. Use vertical strips, same region, about y equals negative 2, 5 minutes. Can I erase this one? Y equals negative 2. Same region, the one I've shaded, but around y equals negative 2. And then use vertical strips, so it'll be delta x. Vertical strips with delta x. Compare. Don't dig a hole for yourself. Check your work with each other. Something's different about this.
Why didn't you want to do horizontal strip?
Because you don't get washers. You get something different. You get a different shape that we'll do on Wednesday. But yeah, and then we'll only have to do one.
Okay.
See, that will be a good starting point on Wednesday. Okay. So this will be two different types of washers. One washer up to the intersection, the apex there, and then a new type of washer out to the end. So the red ones, outer radius of the red ones. It's going to be y plus 2, or minus negative 2. It's this right here. Outer radius is this right here. And that's just the y-coordinate of the curve. And then negative 2, so it's going to be y-coordinate of the curve plus a distance of 2, or minus negative 2. Inner radius, just 2, right? It's just always, for the whole way across, it's 2, right there. But then it's delta x, so y becomes square root of x. It's the curve. It's the y-coordinate of the curve, which is square root of x.
I have a question about
Yeah.
square roots.
Plus or minus?
Plus or minus.
But this one is the plus, right? The minus would be this down here, which is not. So you're right. When you take the square root of both sides, you want a plus or minus. So which one is our curve? That's positive radical x. Yep. Okay, so that's the red setup. Blue. Outer radius is?
6 minus x plus 2.
So it's, again, it's y plus 2. Oh, sorry, that's squared. And then again, it's 2. The inner radius is 2. I forgot my squareds here. Squared. These are all squared. All right. So it's going to be pi times y. What's the y? The x. What's y equals 6 minus x. So it'll be 6 minus x plus 2. 6 minus x is this distance right here. It's the y-coordinate, and then you're going to add 2 more to get that whole outer radius. Minus pi, 2 squared delta x. So this one will be, and what was our coordinates of this point right here? 4, 2. So this one will be from, integrate from 0 to 4. This one will be from
4 to 6.
web work is available right now. It's due at 5:30 Wednesday.
Single rectangle right here.
So the region is up here. The region is up here. We're going to rotate it around equals -2, and we're going to add a draw, and we're going to get this thing. Okay, it's like a,
Like an order slice.
no, it's going to be like a
Semicircle.
napkin holder. It's going to be like this. That's not a great drawing.
Okay, I get the concept now. So when you flip it over on this side,
It's going to be something like that, like something like that.
and so this you're moving here, and this.
No, the region you're rotating around y equals -2.
Okay.
Here's the region. You're rotating that about y equals -2.
Okay.
So here's the original region. Imagine that going around in a circle. Flat going around.
Okay.
This whole thing goes around y equals -2.
Okay. Because I thought this one to y was negative. That's where I was.
No, it's rotated around y equals -2. So then it comes all the way down here. When it's 180 degrees, it looks like that.
Okay. I get it now.
See it?
Yeah. Because I thought it was just
So
two.
This is the original region right there. And then you rotate all the way around y equals -2. So there's this whole big gaping hole here from 0 down to -4. That's all a hole. It's all open there.
Okay. Thank you.
You're welcome. Oh, yeah. Can I erase this, Chris? This problem?
Yes, sir.
You're good? So what was it again?
It was find C is greater than 0 such that the area of the region enclosed by the parabolas y equals x squared minus c squared and y equals c squared minus x squared is 200.
Okay. So what happens is, did you sketch these two parabolas? So that one opens up, and it intersects at c squared down here. Is that right? And then this one opens down, and it has a y-intercept of positive c squared, right? This is negative. So what happens is this is positive c squared. And they end up having the same y-intercepts, right? Did you get the y-intercepts? Did you get them? So basically, what values of c are going to make y equal to 0? So what's going to make y equal to 0? Oh, so what values of x will make y equal 0? Yeah. C and negative c. Do you see that? And so they want this entire region, its area to be 200. So we could make this easy on ourselves, and we could use symmetry, right? This is totally symmetric about the x-axis. So what could we do to make it easy? This whole,
Take the half to
and make it equal to?
100.
Yeah, so the total area has to be 200. So if we did this and forced it to be 100, so say A star, we make that 100, it would be the same value of C. That would make the whole thing 200, is that right? So now can you set it?
See it now.
Okay, so
I was thinking of it like cancel each other out because what's below the x-axis? I didn't get the problem.
okay, so set it up for me. So now we want, what would you do? We do a strip? So what would the area of a strip be? Delta x times y. What'd you say?
So x squared minus c squared.
Right, it's going to be the y coordinate, which is x squared minus c squared. Okay, so that's going to be the area of our strip. And we could still make this even easier. What could we do? So the total area is equal to, let's make it even. How could you make it even easier? Do the same technique again. So the area total would be what? Integral from right, and so, and that would equal to 100 or 200? That would be our 100, right? So that's actually area star, what we call A star. Which I cross-hatched in red. But we can make this even easier on ourselves when we do the integral. How can we do it? Instead of going from negative c to c.
Yeah, only take the first quadrant.
Yeah, and then what it would be. So just the first quadrant would be 0 to c. And that would equal? No. What should that whole integral equal? What value? 50. This is the easiest. Because we're going to have a polynomial and we can plug 0 in. We don't have to plug all the negative c's in. It's going to be nice to plug the 0 and just have those go away, right? Okay, so you said 1/3 x cubed minus what? C squared x from 0 to c equals? Okay. So this equals, we got to simplify this. What is it? Good. Right? Uh-oh. What happened? We got a negative. Where did we go wrong here? Oh, because we did pick the wrong one, right? So this, the y coordinate of this is not x squared minus c squared. What is it? This is c squared minus x squared. So if we track all that down, we just get the opposite of this in the end, right? So in the end, we're going to get, this is going to be c squared x minus 1/3 x cubed. Do you understand? I'm going to do this easy. So c squared minus x squared. Which is? It's meant to be. Okay, so we're home. We almost got it. 175. 150 divided by 2. Cube root of 75. We'll make that thing equals 50, so the whole thing will be 200. Did you follow it?
Yeah.
You agree?
That's hard. Okay.
Yeah, you just gotta be okay with working with a parameter, right? So it's just you do everything the same, except you have a parameter you don't know what it is, and you do know the final answer, and then you can get to a place where you can solve for that.
Thank you.
So let me turn the video off here. I'm glad you asked about that. So that's on the video, because I'm sure other people had a question about that.